Today, we're going to dive into two companies that are basically two sides of the same, really fascinating coin. Dart Meadow, an aerospace firm, and Radical Deepscale, the software powerhouse that's making their biggest ideas possible. See, together, they're not just making new stuff. They're actually building a whole new toolkit to engineer the future by going after one of the oldest problems in science: chaos.
All right, so let's get right into it. The story really kicks off with a massive physical challenge. We're talking about trying to create brand new materials that can survive the most extreme environments you can possibly imagine. Think about the mind-bending heat and pressure of hypersonic flight. And this isn't just some theoretical idea. Dart Meadow lays it out right there in black and white in their own documents. The goal is crystal clear: create a totally revolutionary tungsten-based alloy. They call it T11-Z, built specifically for the insane demands of hypersonic engineering. So that leads to the million-dollar question, right? It's one thing to say you want to make a new material, but how on earth do you actually design a recipe for something that has literally never been made before? Where do you even start designing and testing something that only exists as an idea?
I mean, just look at how complex this recipe is. This isn't just about melting a couple of metals together. The main idea is to beef up tungsten, and they're using nickel as the backbone for its heat and corrosion resistance. But then you've got this whole suite of catalysts: boron, zinc, silicon, and more, all being put through some proprietary system. It is an incredibly delicate, super high-stakes balancing act. So how do you even begin to manage that kind of complexity without blowing millions of dollars on physical prototypes that might not even work? Well, you build a digital forge. And this is where our story pivots, shifting from the physical world of material science into the digital world of software. And the answer is Radical Deepscale. They're the ones building the unbelievably sophisticated software that lets Dart Meadow's engineers simulate, tweak, and perfect these materials inside a completely virtual environment. Their flagship piece of software is called ArcLake Chemistry. You should really think of it like a virtual laboratory. It's a place where you can build and break materials at the molecular level way before you ever have to fire up a real-world furnace. Inside ArcLake, the engineers have what is basically godlike control. They can literally pull apart molecular structures, run incredibly detailed physics simulations, and even adjust fundamental forces like gravity and temperature. Now, you might have noticed something on that list called the arc edge factor. Keep that name in the back of your mind, because it's the secret ingredient that makes all of this possible. So here's the thing. To build a digital forge like ArcLake, you actually need a new kind of math. You can't simulate the messy, chaotic real world using perfect, predictable equations from a textbook. You need a completely new way to measure it. And listen to how the system's creator, Justin Venable, explains the core concept. He says traditional math is great for perfect, symmetrical shapes, like a circle. But the real world is made of what he calls finite arcs. These are unpredictable, asymmetrical curves. Arc Edge is the system he designed specifically to measure these chaotic shapes. So to put it simply, the secret sauce that powers all of Radical Deepscale's technology is a fundamentally new way to measure chaos. By figuring out how to mathematically define the unpredictable, they can simulate it with incredible, game-changing accuracy. This slide really lays it all out for you. On one side, you have your predictable, symmetrical systems. Perfect circles and ellipses. Easy stuff to measure. But on the other side, you've got the real world. Chaotic, finite systems. Think about the swirling path of water going down a drain, or the jagged, unpredictable pattern of a lightning strike. Your standard measuring tools just completely fail here. And that is exactly the problem that Arc Edge was built to solve. And believe me, this is no one-trick pony. The Arc Edge principle is so fundamental that they've already applied it to a whole range of tools. Everything from a 3D graphing tool for plotting these wild curves, to an audio visualizer that can measure the finite arcs of sound waves, and even a plugin for the popular 3D software Blender just to analyze fluid dynamics. Okay, so if you can create a system that can accurately measure physical chaos, what's the next logical step? Where do you go from there? Well, you aim even higher. You turn your attention to the most complex and chaotic system we know of: intelligence itself. So this is Ariel. It's a prototyping tool for what's called a neural processing unit, or NPU. And what it does, and this is really critical, is it simulates how an AI model that's built in software would actually behave when it's running on specialized AI hardware. It bridges a huge gap between AI theory and how it actually performs in the real world. And this is where things get really, really interesting. The core logic that drives Ariel is called the tripartite buoyancy reflex. Yeah, I know, it's a mouthful, but stick with me, because it's an incredibly powerful framework for understanding how this AI actually thinks.
Let's just break that down. The logic is built on 3 pillars. First up, you have the foundation, which is all the AI's base knowledge plus the current context of a conversation. Next, there's the reflex. That's how it spots patterns and pulls up the right information. And finally, you have performance, where it all comes together, and the AI synthesizes a final, proportional response. It's a constant dynamic balancing act between these 3 parts. But here's what's really wild. You're not just a spectator here. A tool called the Ash Canvas Influence actually lets you visually program this logic. You can quite literally sculpt the connections between concepts, programming the AI's thought process in a much more intuitive, hands-on way. Okay, so we've gone from hypersonic alloys to molecular simulations, all the way to a new framework for AI. Let's take a step back and pull all these threads together to see the single, cohesive vision that connects all of these incredible projects. And this logo, the Dart Dovetail, it really says it all, doesn't it? It represents the completely unified ecosystem of Dart Meadow and Radical Deepscale. It's a symbol for a vision where digital tools and physical engineering aren't two separate things, but are actually two halves of the same whole. When you look at the whole picture, you can see this incredible journey of discovery. It all started with a very concrete physical need, a better hypersonic alloy. That need demanded a digital solution, which was the Arc Lake simulation tool. But to power that tool, they needed a new core principle, the ArcEdge mathematics for measuring chaos. And what's the ultimate application for a system that can model chaos? Well, it's a new framework for artificial intelligence. And that leaves us with one final massive question. By focusing so intensely on creating these fundamental tools to measure, to simulate, and to engineer chaos, are Dart Meadow and Radical Deepscale actually building an entirely new foundation for how we will engineer the future, from materials all the way up to minds?